Okay, this is lesson 5.1. It's about roots and radical expressions. This is the first lesson in our unit about radical equations and rational exponents. So we're going to talk a lot about radicals, and then we'll get to the rational exponents later. But today we just want to evaluate and simplify some radical expressions. So what is a radical expression? Well, it's a different way of writing an exponential expression. So if I say that 3 to the 3 squared equals 9, and the way to write that is that the square root of 9 equals 3. It conveys the same information but written in a different way. So we're both ones say that 3 times 3 equals 9. 3 times itself twice equals 9. Likewise, if I had 125 equals 5 to the third, I could rewrite that as 5 equals the cube root of 125. You see, I know it's a cube root because I have that little 3 on the outside. That little 3 is referred to as the index. And for the first one, the square root of 9, since there's no number written as the index, whenever that you see that, you have to assume that the index is 2. So the third one, if I have 12 to the fourth power equals 20,736, which it does, then a different way to convey that same information by using a radical, which is what that little square root sign is, it's called a radical, is to write that 12 equals the fourth root of 20,736. So you say I could rewrite roots to get rid of the exponents. I can write them if I don't know what the root is, if I don't know what the exponent is. It's all different, a different way of writing the same information. A lot of the times, you'll be using a calculator to figure this out, but what won't help you is when we have positives and negatives, because sometimes, we'll have to be careful about negative numbers. So since 2 to the fourth and negative 2 to the fourth are both 16, okay, they're both 16 because negative 2 times negative 2, if you look at that out, you're going to get a positive number because you have an even number of negative numbers that you're multiplying together. If you multiply negative times a negative, it's a positive, and so forth and so on. Another negative makes it negative, another negative makes it positive. So it kind of goes back and forth between negative and positive as you multiply more of the 2's. But both of them give a positive 16. So if I asked you for the fourth root of positive 16, you'd have to tell me both 2 or negative 2, because it has 2 potential roots. The calculator is only going to give you 2. So you have to know whether or not to have 2 answers or only have 1. Because if you have something like 5 to the third, 5 to the third equals 125, but negative 5 to the third equals negative 125. So if I asked you for the cube root of 125, the only answer is 5. You don't give me 5 or negative 5. You give me 2 answers if the index is even, and 1 answer if the index is negative. It's odd, I'm sorry. So you use a calculator to find them a lot of the time. So if I said find all the real cube roots for 0.008, negative 1,000, and 1 over 27, you go to the math menu in your calculator and you'll see that choice 4 is cube root. So you put in the cube root, you put in the number, you hit enter, not very difficult. For the fourth roots, in the second problem, you're going to have to change things up a little bit. There is no fourth root button in the math menu, but there is an X root button. And so what you're going to have to do is you're going to have to put in what you want the index to be before you hit the math button. So you put in the 4, then you hit math, then you choose choice 5, and you put the number you want to find the root of, and here's the key, in parentheses. If you don't put the parentheses, you will get it wrong when it's a fraction, because it'll only find the fourth root of the top number of the fraction. It won't find the fourth root of the whole fraction. So what we're really doing, and when we're solving these, and I want to get to really doing this, and I'll show you with numbers first, because once we bring variables into it, your calculator is not going to be able to do it. So what you're doing is, if I wanted to find the cube root of negative 8, what you need to do is, in order to cancel out the cube root, you have to have something raised to the third power. Then, just like the same number on the top and bottom of the fraction, they'll cancel out. The root will cancel out with the exponent. So I could rewrite negative 8 as 2 to the third power, negative 2 to the third power. Once I have negative 2 to the third power, the exponent on the inside cancels out with the cube root on the outside, and all that's left is negative 2. You would do a similar thing for if I was finding the fourth root of 10,000. 10,000 is 10 to the fourth power, so the fourth root on the outside cancels out with the 4 exponent on the inside, and you'll be left with 10. So what about when we have fractions, when we have variables then? Not fractions, variables. Well, it gets a little bit more complicated, but not that much more. So we have 4x to the 6th power. Again, the index for this one, because there's no index written, we'll assume to be 2. So I'm going to break it down first. I'm going to just put each term, each multiplying term, into its own radical symbol. So here I have the square root of 4 times the square root of x to the 6th. Well, 4 I can rewrite as 2 squared, and x to the 6th I can rewrite as x to the 3rd squared, because when you have a power raised to a power, you multiply the exponents together. So 3 times 2 would give me 6. So if you'll notice now, I have the squared can cancel off of the 2, the first 2, underneath the first radical, and the squared can cancel out with the second radical as well. So what's left is 2x to the 3rd. That same thing will work if it's both, if you have 2 variables and no numbers. So I can break this down. That's the cube root of a to the 3rd times the cube root of b to the 6th. The 3 on the a already cancels out, so I don't have to worry about the a, but I need to rewrite the 6th, b to the 6th, to be something that has something to the 3rd power. So what I'd write is that we still have the cube root of a to the 3rd. Nothing changes there. Then we have the cube root of b squared to the 3rd, because remember 2 times 3 is going to give me 6, and I need that outside number to be 3 because I need to cancel out my 3's. So when I do that, I cancel out the index 3 with the exponent 3 with the a, and I cancel out the index 3 with the exponent 3 on the b. What I'm left with is ab squared. One more example. If I had the 4th root of x to the 4th times y to the 8th, again I break it down into 2 separate things. That's y to the 8th and the second one, by the way. 8 needs to get broken down to something to the 4th power, and 8 is 2 times 4, so it's y squared to the 4th power. And now I can cancel out all the 4's, and I'm left with xy squared. So that's the 2 types of things you're going to do. You're going to do calculator work. If you don't have a TI at home, you can probably find something online that will find n roots or x roots, 4th, 3rd, and 4th roots definitely. And then we'll have the ones with the variables to do those. Here's your homework. It's numbers 2 through 32 even on the workbook. I'll take a picture of it and put it on Emoto. Good luck, and I'll see you in class next time.